we would like to use the third form of curvature to find the curvature kappa for two space curves. The first being r of t equals t, 2t, 3 plus t squared, and the second being a cycloid, which is actually a plane curve, not a space curve. And the formula for the cycloid is r of t equals t minus sine t, 1 minus cosine t, 0. Plane curve, so the z component is 0. Okay, the third form of curvature. So kappa is our curvature. The idea of it is that it's the magnitude of the rate of change of the unit tangent vector with respect to the arc length parameter. Now, the arc length parameter is sometimes a little bit of a challenge to have access to, so we have a second form of curvature where we just have any parameter t, and it's the magnitude of t prime of t, where again t is the unit tangent vector to the curve r, and then divided by the speed of the curve, the magnitude of r prime of t. Now, it turns out that the magnitude of t prime of t can be expressed in terms of the cross product of r prime and r double prime, and so we get that this fraction happens to equal the magnitude of r prime cross r double prime divided by the magnitude of r prime cubed. So this one is the third form of curvature. It doesn't require us to find the unit tangent vector in particular, and it doesn't then require us to take the derivative of that vector. All we need is r, take some derivatives, a cross product, and some magnitudes, and we have the curvature. So for the first one, r of t is t, 2t, 3 plus t squared. So we need r prime of t and r double prime of t. R prime of t is 1, 2, 2t, and r double prime of t is 0, 0, 2. So then we need the cross product of these two vectors. So r1 cross r2, r prime cross r double prime is equal to, we make a matrix, a 3 by 3 matrix. Here's I, j, and k, the unit vectors in the x, y, and z directions. We put the first vector in the second row here, so that'll be 1, 2, 2t, and we put the second vector on the third row. The order matters. In a cross product, this vector goes first, and then this vector below it, 0, 0, 2. And now we calculate the determinant of this 3 by 3 matrix. That's what these vertical bars mean. They mean determinant. The determinant turns a matrix into a scalar quantity. And that determinant is computed by doing the vector I times the determinant of this little 2 by 2 matrix here. The determinant of a 2 by 2 matrix is the difference in the products of the diagonals, AD minus BC. So this would be I times 2 times 2 is 4, minus 2t times 0 is 0. And then we go to j and to k. Now when we go to j, we have to do a minus. So minus j, it's plus minus plus. So j times, and we do the determinant of the matrix 1, 2t, 0, 2. We remove the j column, and we're left, and the ijk row, and we're left with 1, 2t, 0, 2. And the determinant of this is 2 minus 0, which is 2. And then we have plus k times the determinant of 1, 2, 0, 0, and that is 0. 1 times 0 minus 2 times 0 is 0. So this determinant is 4i minus 2j, which is the same as the vector 4, negative 2, 0. 0k. I, j, k. So there's our cross product. The magnitude of our cross product is the square root of the sum of the squares. And that's the numerator of our curvature. So that's the square root of 16 plus 4 plus 0. That's the square root of 20, which is, there's a 4 in there, so that's 2 times the square root of 5. And then the magnitude of the denominator, we need the magnitude of r prime, and we have to cube that. The magnitude of r prime is here. The magnitude is the square root of 1 squared plus 2 squared plus 2t quantity squared, which is 4t squared. And that's the square root of 5 plus 4t squared. And therefore, in this first problem, kappa is, the curvature is, the numerator was 2 root 5, and the denominator is the cube of this guy. So 5 plus 4t squared, square root makes 1/2 power, and then you cube that, and that makes 3/2 power. So our curvature is 2 times the square root of 5 divided by the quantity 5 plus 4t squared to the power 3/2. And now for the cycloid. Let's look at that again. T minus, so the cycloid, R of t is t minus t sine t, and then 1 minus t cosine t, comma 0. Hold on a second. Sorry, there's no t's in front of the sine and the cosine. So it's just t minus sine t, 1 minus cosine t. So what is a cycloid? If you have a circle rolling along level ground, and you keep track of a point as you roll the wheel, the circle, along the ground, and that point is going to go up and down, something like this, and that is a cycloid. So we want to know the curvature of the cycloid. So we need r prime and we need r double prime. R prime is 1 minus cosine t, and then this is sine t, and then 0, and we need r double prime, which is negative sine t, no, positive sine t, cosine t, 0, and then we need the cross product. So r prime cross r double prime, determinant ijk, r prime goes first, 1 minus cosine t, sine t, 0, sine t, cosine t, 0. So the determinant is I times 0, because sine t times 0 minus 0 times cosine t, and then minus j. J, take out these guys and those guys, and you get 0 again, and then plus k times, and we have the determinant of this one here, which is 1 minus cosine t times cosine t minus sine t times sine t. And this is cosine t minus cosine squared t, and then minus sine squared t, and that looks like cosine t minus 1. So k times cosine t minus 1. So our cross product, the numerator, is the magnitude of the vector 0, 0, cosine t minus 1, and the denominator is the cube of the magnitude of this one. So the magnitude of the vector r prime of t, which is 1, r prime of t, 1 minus cosine t, sine t, 0, and we have to cube that one. So let's work this out. This is 1 minus cosine t. Cosine t minus 1 is going to be negative, or maybe 0. So the magnitude will be the absolute value of this, which is certainly 1 minus cosine t. And then divided by the 3/2 power, because we have a square root for our magnitude, and then a third power. So we'll put a 3/2 power, and we have 1 minus cosine t squared plus sine squared. And I have a feeling we're going to get a cosine squared plus a sine squared out of that. This is 1 minus 2 cosine t plus cosine squared plus sine squared t. There should be a t there. And cosine squared plus sine squared is 1. So this is 2 minus 2 cosine t. So it's 2 times 1 minus cosine t, which is exactly what we have in the numerator. So 2 times 1 minus cosine t. So we have 1 over 2 to the 3/2 times the square root of 1 minus cosine t, because we get cancellation here. 1 minus cosine t to the first power divided by 1 minus cosine t to the 3/2 power leaves us with 1 minus cosine t to the 1/2 power in the denominator. So there's the curvature of our cycloid. The curvature of our cycloid is minimized when the cosine of t is 0 and the cosine of t is 0 at 90 degrees. And this would be at this point. That's where we have a minimum. And it's maximized where the cosine of t is 1. And that would be at this point. And we have the curvature is actually undefined at that point. Okay, that's a 1, and that's a wrap.